Today, I present our analysis on the expansion plan for EV Auto Part Malaysia, focusing on the optimal location for our new manufacturing plant. So, for introduction, EV Auto Part Malaysia is a leading manufacturer of electrical vehicle components, specializing in essential parts like battery packs and LiDAR device. As the demand for electrical vehicle and autonomous driving technologies grows, we aim to expand our operation, which include establish a new manufacturing plant to meet our rising demand. Now, let's dive to our product. At EV Autopart Malaysia, we focus on providing high-quality parts specifically designed for the electrical vehicle. Our core offering is, of course, LiDAR device. So LiDAR technology in particular is crucial for autonomous vehicle as it enables high-resolution 3D imaging for precise environment detection. This innovation enhances safety and efficiency in self-driving systems. As the demand for the EVs and autonomous technologies grows, we are committed to expand our operation to meet this need, particularly in the production of our advanced LiDAR devices. So for that, it's important to select the new location for our new manufacturing plant, as it is vital as it impacts operation cost, efficiency, and our ability to meet customer demand. A strategically chosen site ensures timely delivery, reduce transportation costs, and provide access to the skilled labor and suppliers. For that, we select three locations, which is Shah Alam, Batu Gajah, and Kuantan that met our selection criteria. So for the methodology, we apply establishing decision-making framework for location analysis. Each method provides insight into the financial viability and logical efficiency of the potential site. The methods are break-even analysis, factor rating method, and center of gravity method. We also assess transportation option to ensure cost effectiveness. So let's break down to the break-even analysis. Break-even analysis helps us understand the point at which total equal cost revenue. Our finding reveal critical crossover point at 1,000 unit. Batu Gajah and Kuantan have equal cost, and at 2,500 unit, Kuantan and Shah Alam do. This analysis shows that Shah Alam become favorable at higher volume. In summary, if we expect sale below 1,000 unit, Batu Gajah is the best option. For sale between 1,000 and 2,500 unit, Kuantan is optimal. Above that, Shah Alam is ideal due to the lower variable cost. We recommended evaluating expected sale volume closely. If below 1,000, choose Batu Gajah. Between 1,000 to 2,500, option for Kuantan. And above that, select Shah Alam. Regular cost monitoring and the long-term planning are also essential. Let's go through to the second method, which is factor rating method. The factor rating method evaluates key success factors for each location. Shah Alam scored the highest at 86.25, indicate that it the most favorable site based on the proximity to automotive OEMs, skilled workforce, and infrastructure. So let's go through to the COD method, which is center of gravity method. Using the center of gravity method, we determine that Shah Alam minimizing transportation costs effectively. A central location relative to supplier and customer enhance logistical efficiency. So in conclusion, Shah Alam is the optimal location for our manufacturing plant, providing the best balance of the cost and infrastructure. And also, Kuala Lumpur is recommended as the warehouse location, as we have found that Kuala Lumpur is the optimal location that can contribute to Kuantan, Shah Alam, and also Batu Gajah. So it will enhance logistics even if we select others location. So that's all. Thank you for your attention.
Assalamualaikum and very good morning everybody. So today I would like to present on transportation viability analysis by my company EV Auto Parts Malaysia Sdn Bhd. My name is Ramzi. Okay, so first of all I would like to highlight what is my outline for my presentation. Number one, I want to see and explain about the purpose of analysis. Number two is our analysis in terms of northwest corner analysis, intuitive lower cost analysis, stepping stone, and finally is our summary. The purpose of analysis. What is our objective? Actually, we want to find the most efficient and cost-effective routes of our transport goods from factory to the warehouse. The most important objective number 2 is identify the lowest total cost of transportation goods while we can fulfillment of the supply and demand constraint. Before we go further, let me introduce our factory location. Our first factory located at Shah Alam. Number 2, Batu Gajah. Number 3, Kuantan. Our warehouse location at Tanjung Malim, Perak. Kuala Lumpur at Central Region, and Nilai, Negeri Sembilan. First of all, I would like to explain about the Northwest Corner Rule, our first analysis. It's very straightforward and easy, an initial feasibility solution analysis for transportation problem, and before go for the more detailed analysis. Let's discuss the result of the analysis from Northwest Corner Rules. So this is a table that used to do the analysis for this method. So we have a factory, we have warehouse there. So we need to, starting from the top left corner, and then we can exhaust the supply for each row, column, until all the requirement is satisfied. So as a result, so this is a total cost. We got around ringgit Malaysia, 2,975,000 ringgit. Okay, so next we discuss the second analysis method, which is intuitive lowest cost. This method actually they focus prioritize on the assigning unit to the routes with the lowest transportation cost.
So this is the intuitive lower cost analysis. This is our result. So what we can start is identify the lowest cost cell first, and then we need to allocate the unit, and then we need to cross out cell row and column. One is already exhausted, and then we find remaining cell with the lower cost, and we need to ensure all demand and supply exhausted, and we need to count what is the total cost of the transportation. And then we continue all of the process, find out the most lowest cost in the cell until we complete all cross out.
So from this intuitive lower cost analysis, the total cost that we can calculate is around ringgit Malaysia 2,350,000. Okay, let's discuss about the third method of analysis, which is stepping stone. This is very interactive improvement technique that start with the an initial feasible solution. In our case, the initial feasible solution is we start with the Northwest Corner Rule and followed by stepping stone analysis.
So this is stepping stone is very interesting. Normally we can start with the identify index is a viable or not. For this case, the case number 1, you can see plus 100. So we can use it for further analysis, and then we can select unused square to evaluate and trace closest path back to original square, and we assign plus minus unit, and we can identify total cost. So for this the total cost for the first case, which is Shah Alam factory to the warehouse Nilai, is all about 2,625,000. We find the next unused square, which is factory Shah Alam to the warehouse Kuala Lumpur. So finally, after we got the calculation, so the result is ringgit Malaysia 3,025,000.
So for the summary, I would like to focus based on the three type of analysis. What is the lowest cost? Number 2, we want to find the efficient and low cost routes. Number 3, what is our future analysis proposal for further improvement?
This is total cost comparison by 3 different analysis method. Based on my analysis, the most lowest cost is around ringgit Malaysia 2,350,000 by intuitive lowest cost. This is the most lowest and optimal for transportation viable.
As a summary also, we can identify the lowest cost road. Route number 1, BG2TM, Batu Gajah Factory to Tanjung Malim Warehouse. Route number 2, SA to KL, Shah Alam Factory to Kuala Lumpur Warehouse. Route number 3, BG to KL, Batu Gajah Factory to Kuala Lumpur Warehouse. Route number 4, KU to NI, Kuantan Factory to Nilai Warehouse. This is the most effective route with the lower cost.
In future, we plan to do further analysis on transportation viable by using method intuitive lower cost and followed by the stepping stone, and then we do the modified distribution method MODI, linear programming LP, and Vogel's approximation method VAM.
That's all my presentation about transportation viability analysis for AV Autopart Malaysia Sdn Bhd.